Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, thank you. Okay. Just we're waiting 1 minute for joining all of those other participants. Then we'll start. Okay, just a minute. Okay, so we will start now. So basically, today is our fifth number of class, and basically today I also try to discuss about that air quality monitoring. Okay, so how we can easily make the air quality parameters, mainly monitor the different types of gases. It can be carbon dioxide or carbon monoxide, formaldehyde, methane, nitrogen dioxide, sulfur dioxide. So these type of gases, how we can easily monitor using the remote sensing technique. So today's session I also try to discuss about all of those things one by one. So let's go. Just I simply share my screen. Mm, Okay, can you see my screen now? Okay, is it visible? Okay, thank you. Okay, so let's go. Let's start. So basically, today we try to complete this type of thing. Suppose air quality monitoring, all parameters we try to discuss, mainly carbon dioxide, carbon monoxide, formaldehyde, sulfur dioxide, methane, all of gases, how we can easily monitor using the remote sensing technique. I also try to discuss all of those things one by one, and how to download the air quality parameters time series data in CSV format using Google Earth Engine platform. We are also download the data in CSV file format and use it, as well as how to make the air quality monitoring time series chart, how to calculate the total emission of nitrogen dioxide or sulfur dioxide or any gases using Google Earth Engine platform. What is the total emission for any particular gases? We also try to discuss about that, as well as in this time also try to discuss about that ArcMap software. Basically, it is ArcGIS, mainly ArcMap. This tool, how we can easily use and then create the map after downloading the tip image from Google Earth Engine platform. We have to use the ArcMap software to produce our map. It can be research paper map or any other kind map we can easily produce using the ArcMap. Okay, so this time we can try to complete one by one. So let's go. So first of all, here you can see basically in this time, here you can see this is the one kind of map. So basically in this time, here you can see this kind one map is the methane concentration map of Kuwait, and we can easily find out this type of region. We find out that high concentration of methane. Okay, and this can identify about the low concentration about the methane. So in this time, we just download the data after processing in Google Earth Engine platform as a TIFF format. This data, this TIFF format, we are use the ArcMap software to create this type of map, such as methane concentration map of Kuwait. And here you can see the methane. What is the unit about that? Unit is the ppb. Also, is another kind of map. It's the nitrogen dioxide concentration map, year of 2020. month of January. Here we can find out this type of color, identify about the high concentration, and this type of color about the low concentration. So here you can see the unit about the mole per meter square. Okay, so we can easily convert this type of unit, mole to micromole or mole to ton. This type of how we can easily convert, I also show you the later about this in our session. And also you can see this is another nitrogen dioxide levels rebound in Bangladesh for the different time period, such as before lockdown, during lockdown, or post lockdown. So basically in this time we also make some classes, such as you can see level of nitrogen dioxide concentration very low, then low, medium, high, very high. So we are just make the some classes, and we find out this type of distribution for the different types of time period in the lockdown period we can get in the COVID situation. So these type of things we can easily create using Google Earth Engine platform, and further we can download as a TIFF format, and this TIFF format we can use in ArcMap software to make this type of map. So I also show you that how we can easily create this type of map in ArcMap software. Okay, so basically in this time we are applying this Sentinel-5 satellite imagery. Okay, this Sentinel-5 satellite imagery we are use and then create this type of map. Mainly Sentinel-5, this satellite image focused on air quality and composition, climate interaction with the main data products, mainly ozone, nitrogen dioxide, sulfur dioxide, carbon monoxide, methane, formaldehyde, aerosol. So this type of gases we can easily access using the Sentinel-5 satellite imagery and then monitor. So first of all, I can see this is the one kind of link. So this is the dataset link. So you can simply copy the link and open in your browser. It automatically open in your dataset. This dataset will be open. So or if you want, I simply go to my code link or code editor. Simply select my specific Gmail which I used, and now it opened my code editor. So this code editor, I can easily access all of those dataset from browse data catalog. Here you can see the browse data catalog. Simply click on here. So now it open all of those dataset. From here I can easily find out the Sentinel-5. Okay. So here you can see Sentinel. Just click on the Sentinel, and then further you can easily access all of the Sentinel image collection here. Here you can see the Sentinel-5. In this time we are use it. It is a Sentinel-5 tropospheric monitoring instrument. So basically this type of things, such as aerosol index, then cloud, then carbon monoxide, formaldehyde. Also you can see the nitrogen dioxide, ozone. Also you can see about the sulfur dioxide, methane. So this type of gases you can easily access from here and then monitor. And this data set for the globally, we can easily get any region in the world because it's a global data set. So in this time I will show you that how we can easily work with that. Suppose I want to work for that carbon monoxide, okay, and then monitor the carbon. So for that I just simply click on here, then I can easily get all of those information about this data set. So basically this data set we can easily access between this time period, year of 2018 to 2024. Okay, and this is the dataset provider, European Union ES Copernicus, and it's a Earth in snippet. So it's a unique ID of this dataset. And here you can see mainly description about this dataset. Mainly carbon monoxide is the important atmospheric trace gases for understanding the tropospheric chemistry. It's certain urban areas, it's major atmospheric pollutant. Main source of carbon dioxide you can see mainly combustion of fossil fuels, biomass burning, atmospheric oxidation, methane, and the other hydrocarbon. Okay, so for this region, this is the main source of the carbon monoxide. So in this time we can easily find out this type of things. Here you can see they are already provide the different types of band. Here you can see it's one kind of band. This band mainly carbon monoxide column number density. And when I want to make the concentration map or density map of carbon monoxide, then I can easily use it. Carbon this band carbon monoxide column number density, and this unit is the mole per meter square. Okay, and also you can see, if you want, you can also monitor the water column number density. So basically, if you want to identify for that water column number density on the air, then you can easily use it. You can see it's the water vapor column. Okay, so you can see the cloud height, there are a lot of information included in here, but in this time we are just talking about this band. Okay, basically we want to make the density map or concentration map of carbon monoxide, and here you can see unit is the mole per meter square. Okay, so this is the mole per meter square. So in this time I want to use this data set, and then further I want to make the carbon monoxide map, as well as we also try to find out what is the temporal changes, mainly time series chart for the different time period, what the scenario of carbon monoxide for any particular place. So this type of thing I try to discuss. So first of all, this data set I need to import in my code editor. Okay, so how we can easily import? Simply easy, you are simply copy this snippet ID or unique ID, simply copy this ID and paste on your code editor. Okay, it look like that. Then give a variable name. Suppose I put the name is that data set, or you can put any name. Okay, so in this time this image collection is stored in this variable, and this image collection include lot of band. You can see we already show lot of band, but in this time I want to work only for this band. So I simply copy the band name and use a function. Mainly I select this band, so use the select function and put this band name. Okay, so now from this image collection I select only for the one band, which is carbon monoxide column number density. Okay, and here you can see this data set availability is that this time period. Okay, I want to need only for the specific month or specific year or summer season or dry season or any specific time period. So for that I simply use a function, this function called filter date function. So use here the filter date function, and further put here your specific time period, start date and end date. Suppose I put the time period year of 2024, suppose 1st January, from year of 2024 suppose 1st January 31. Okay, I take this month of January, year of 2024. So this is my data set. So now all of those things is stored in a variable, this variable called the data set. Okay, so now I want to check how many images are in this collection, how many images in this collection, and to check it. So for that I just simply print this data set. So I simply use here the print. So just use here the print function and then check how many image collection I can got. So call this and use here the size function. Now it printed number of image collection, how many image collection I can got for 1 month. We find out total 420 images. Okay, so this is the total image collection for 420 image collection. You can find out month of January, year of 2024. So this is my collection, this is my image collection. And when you want to make the time series chart, then you need this image collection. Okay, suppose I want to make a time series chart. Suppose I want to make this time series chart. Suppose I simply take a marker. Suppose this is my study area. Okay, I want to choose, this is my point. So this point is my study area, and now I want to find out what's the situation, mainly this time period, when the carbon monoxide concentration is the high and when the concentration is the low. I want to find out. So further I need to make the time series chart. I already make the image collection. You can see 420 image collection between this time period. So now I just simply use here UI dot chart dot image dot series. So this is the function. When you want to make the time series chart for any data set, this is the function. And just simply put all of this argument here. You can see first argument is the image collection. Image collection. So in this time you already make the image collection, 420 image collection. So in this time I simply make a dictionary. So curly bracket start and also curly bracket end, and then further image collection, mainly it's your data set, because this variable stored the 420 image collection. Okay, I simply paste here. Then region, in this time my region is this point is my region, and it's stored in the geometry. So simply copy the geometry and paste here. Reducer, I want to calculate average result, so use here ee dot reducer dot calculated the average pixel of carbon monoxide. Scale mainly is the resolution of your satellite images. So what is the resolution about that? You can see this resolution is that 1113.2 meter. So just I simply copy the number, it's a resolution, paste here. The next property we are using the default as a system time start. So this is the code for making the time series chart. So now this whole things I just stored it in a variable. Suppose I put the variable name is that chart and equal. So now this whole things stored in a variable. So just simply use at the print function and call the chart. Simply copy and paste here, and then click to the run. So now it create the time series chart what the scenario of carbon monoxide between this time period for this location. Okay, good. Here you can see you can get this type of chart. I also run again. Okay, so here you can find out this type of value. Here you can see, here you can find out the value. Mainly it show about that of January 1st January. For this study you can find out 0.3. Mainly unit is the mole per meter square. Okay, this unit is the mole per meter square. You can see the 0.31 also increasing or decreasing. We can get that it's the 0.35 mole per meter square in the January 7th January. Also you can find out that January 9 0.025. Also you can see that result, and 19 January 0.035 mole per meter square. So it shows the different time, mainly this time of the carbon monoxide for this study area. You can simply drag and put the other place. Suppose I am looking turn, I simply paste in here and then click to the run. So now we can get, for suppose you want to monitor any specific building, what the situation of the carbon monoxide, or any kind of coal mining, or any kind of any region where the all time for the produce the carbon or biomass burning all time. You want to check about that, you can simply, suppose if you can simply click on the satellite, then it also better. You can easily get the large view about all of those feature, all of those things you can easily get. Then you can easily monitor all of those things from here. Suppose I click on here, then I can get what the decision about that. So it now it's about that between this time when it will be high, you can get 0.41. Or I simply search here, suppose one kind of coal mining, suppose Boropukuria. Just I simply search this place and also open the satellite view. Okay, then simply zoom it. So basically it's one kind of coal mining station. Basically it's a coal production. So that's why in this time we all time the different types of biomass burning or fossil fuels burning all time. So that's why you can easily find out the more concentration about the carbon monoxide, this type of gas, so you can easily get from here. Okay, so in this time suppose I want to check about that, what is the situation about that. So for that I simply remove the previous geometry, and now I just simply draw my study area. Suppose draw the rectangle. Suppose it's my study area. I simply or it also better to use here the line feature. So just I simply click on here and just draw. Suppose it's my coal mining production area. I simply select my study area and so double click. So now it's my geometry, it's my area. this area I want to make the time series chart what the scenario of carbon monoxide between this time period 2024 month of January. What is the scenario about that? So now I just click the run. So now it show me the result. What is the situation about the Boropukuria? We can find out these type of things. You can see we can get that very high 0.06. Okay, you can see also increasing, decreasing about that. And this result only show for the 1 month of January 2024. It show the result about that this type of things we can get. Okay, it is the you can see 0.061. Okay, very high. And it is the mole per meter square. Okay, in this time, suppose I want to convert this unit, suppose micromole. It show the result in mole and convert it to micromole. So for that, what can I do? Suppose I want to make the time series chart in the micromole. Okay, so for doing these things, it's very easy. Just we have simply conversion mole to micromole. So for that, I write the code in here. Suppose convert mole to suppose micromole. Okay, so in this time, this result show as a mole, but I want to convert it as a micromole. So for that, what can I do? Very easy. Just we can make a function. So we already know about the function structure. So just I put here, suppose take a variable. I simply put the variable name, suppose micromole. Okay, and then equal sign. And now I just make a function. So call the function keyword function and call the element name. Suppose I put the element name as a image, and further put the curly bracket. In this curly bracket, I just put my argument. What is my argument? In this time, my argument is that I convert mole to micromole. So I simply search on the Google. What's the formula? Mole to micromole. Simply search. Suppose mole to micromole. I simply search. So in this time here you can see the multiply by the amount of this thing. So in this time you can see I just simply multiply this value. Suppose I have a mole result. So now I want to convert in micromole. So just I simply multiply these things with this mole result. So in this time here we put here this multiply this value, mainly this value simply multiply with the mole result. So in this time how we can do that, you can see. So it's a function. I already create this function. So now I simply convert. So just I simply use a function return. So put here the return this image multiply this value, mainly 1,0,0,0,0,0,0. Okay, so in this time when I just simply multiply these things, basically this value, then we can get the result in micromole. But here you can see here it total 420 images. So I need to multiply all of those images at the same time. So for that we are just simply use a function. This function called the copy properties. So use the copy properties and apply this image between the system time start and system time end. So basically this is the, we already discussed about a lot of time, because when I talk about the modis NDVI or other or also modis LST, so I can easily get this idea how it will be worked. In this time, this function I need to connect with my image collection. So just I simply copy the data set and paste here and use the map function for collection connecting and also close this parenthesis. So now further I simply copy the micromole and paste here. Sorry, now click to the run. So now we can get the result in micromole unit. So here you can see we can get this type of things about that. It show about this type of result, and this result is a micromole. because we multiply these things with that. So basically this is the way for convert the mole to micromole. Or if you want not, you need only for the mole result, then simply use the dataset, simply copy and further use it. Now we can get the result in the only for the mole. Okay, what is the mole about that we can get 0.49, this type of things we can easily get from here. Okay, so basically this is the process for creating the time series chart about that. Now suppose I want to make the map, suppose I want to make the concentration map for this study area. Okay, suppose it show the time series chart. If you want, you can also add here the other option, suppose set options, and then put here this title, suppose carbon monoxide time series chart year of 2024, month of January. Okay, I put this title look like that. Further I put here that a vertical axis, mainly V axis, and put the title, suppose this title is that mainly it's that mole per meter square. I put this title. Okay, and Y level mainly X level mainly horizontal axis, S axis. So just put the title. This title represented the time, and now I also put here that suppose enter collect nulls as a true. So now click to the run. In this time, this step option will be added in our chart. Okay, you can see it look like that. So here you can get, suppose click on here. So now you can easily get carbon monoxide time series chart year of 2024, month of January. It's our title, as well as we are also get the mole per meter square. It's just value is the mole per meter square, and it's the time for the different time: 3rd January, 5th January, 7th January, 9th January, 11th January. What's the scenario for the different time? We can easily get from here. As well as if you want, you can also download the data from here as a CSV file format. So basically this is the process for making the time series chart for any location, and basically it's a coil mining station. So that's why in this time we can get the high production of carbon monoxide. You can see 0.63. But other region when you want to work for that, then we did not get this type of high result. Okay, so this is the process about that. So anyone any question you can ask me in here. Anyone any question about this code? For that, any question? Okay, I think everything is clear. Okay, so now I want to make the concentration map. Suppose for this study area I want to make this concentration map. What is the concentration, mainly where is the high and where is the low concentration of the carbon monoxide. I want to monitor it. For doing these things in this time, first of all you have to check about our pixel area. Here you can see this pixel is the large pixel, 1113.2 meter. It's the pixel area. So that's why using this data set we can create the more better map for the big region. Okay, suppose you can easily create the map for the big region, but when you want to apply the data set and create the map for a small region, then we did not get the better result because this pixel area is much bigger. Okay, so we try to add the map, then check what happen we can get. Suppose I want to make this concentration map for this study area. So it's not a mass big area, so it's a small area. So now I want to apply these things in here. Okay, for doing these things, I just need to reduce this image collection. I just take a variable, suppose average carbon monoxide, and then call my image collection data set and paste here. This 420 images I need to reduce. In this time I want to apply the reducer as a mean. I want to make the concentration of mean result. So for that just use here the mean function. and it also clip with my study area. Mainly study area is the mainly geometry. Okay, so now let's check the result. So map dot add layer and call this carbon average CO, simply paste here. So now it loaded this average map between this time period, year of 2024. We can get this type of result. Okay, so now I want to set the visualization. So for that, just click on here, and I just simply custom stressing 98% for vertical looking, and then further we add the plated. Suppose I want to show the low plated as a this type of blue color. Greater than high, I want to show this type of green color, yellow color. Then I want to show this type of red color for the high concentration, and then further apply it. So now it create this type of pixel. You can see it not look more better because our pixel area is much big. Okay, in this time we can get this type of things here. You can see. Okay, in this time you can see basically in this time red color, it's identify about that for this region. We find out that high concentration of carbon monoxide, lower than yellow color and more lower than blue color, this type of things. And it look like that because this pixel area is not much big. Suppose if the pixel area only for the 10 meter or 5 meter, then we also get the more better result. Okay, we can easily identify, we can easily distribution is pixel. But in this time this pixel is 1113.2 meter, but I want to apply my study area is lower than this pixel area measurement. So that's why in this time we can get this type of pixel. But in this time, suppose I just apply the same code for the whole country boundary of Bangladesh, then we also get the better map. Suppose I just simply import my shapefile of Bangladesh, then show the result what we can got. Suppose just I simply import the Bangladesh country boundary shapefile and further remove the previous geometry, and now I just try to apply here the geometry as a variable. And now click to run. In this time we can get the result for whole country boundary of Bangladesh, as well as you also make the time series chart for whole country boundary of Bangladesh. And now we also get the more better map because it's a bigger area. And this result show only for that year of 2024 month of January. Okay, it look like this result. Okay, so in this time we add here the color. Okay, so for adding the color, in this time we just use here their default color. They already provide some color. You can see. I simply copy the code from here and use it. Suppose further paste here. So here you can find out. Simply copy the variable name and add after the object name. Okay. So now click to run. In this time, this type of color will be set. Okay. So mainly high concentration show this type of red color. We can get this type, and black is the show the low distribution or low density about that. Okay, we can get this type of color. Okay, I want to stressing more, look more better this map. So simply click on here. And now further apply it. Okay, so now I can get this type of result. You can see. So now here you can see easily find out the what is the situation, what the scenario of year of 2024 month of January for whole Bangladesh for the carbon monoxide emission. So here you can find out this type of region. Here you can see it shows as a black color. Okay, so basically this type of region is the low concentration. Okay, and also you can see this type of red color. It shows about that high concentration about that. Okay, we can get about these things, and it's the whole scenario about the emission. And you can see this the color bar. So red color bar identify with the high, then lower, then yellow, then green. Okay, and yellow this black color identify about the very very low about that. Okay, then it will be increasing this type of color for the increasing this type of emission concentration in the year of 2024 month of January. So in this time we also get the more better map. But when I apply this image in a small region, then we did not get the better because this is the different on the pixel area. pixel area is high, but my area is low, and then lower than pixel area. So that's why we did not get the better map. But in this time, when we apply the for the big region, then we can easily get the more better map. Okay. So basically, this is a show about that. So just I simply import these things, import, and further copy the visualization from here and add in our. And if you want, you can also put here the name. Suppose I put this name is that carbon or carbon monoxide concentration 2024 month of January. Okay, so now I set that as a layer name in here, and also show about that time series chart.